Hello, welcome to my course Introduction to Market Structures. Today we are going to do bundling and tying. This is the last module of this course. Bundling, one form of bundling we have already done. We have done the monopoly, and in the monopoly we have seen that the monopolist can do price discrimination. And what do we mean by price discrimination? That means that they charge different prices to different quantities, and that is in first degree price discrimination, or they can charge different prices in different markets if the consumers cannot move around from market 1 to market 2, or they will package it in different way. Packaging, and that is a bundling. Like in our case, till now we have assumed that the goods are continuously divisible. So, you can get any quantity you want, but if it is packaged, then it is only available in fixed quantities. You cannot change that quantity. So, that divisibility property, that is gone. So, monopolist can also do that. We have seen that in first degree price discrimination. So, and we have derived in first degree price discrimination that the whole bundle. So, suppose if we have a demand curve like this, then this whole amount, and suppose there is no cost, no marginal cost is 0, then this whole amount, this amount will be packaged at a price which is given by this area below this curve, demand curve, when this is the quantity and this is the price. So, this is we have seen in first degree price discrimination. We have also done graphically the second degree price discrimination, but we will do it algebraically today, and we will consider only the monopoly, because if we take the duopoly or oligopoly, its calculations are slightly more involved. So, we are not doing it. Okay. So, and since monopolist is doing bundling, so this is a form of non-linear pricing, and for simplicity we assume that there are two types of consumers. So, it can have more than two types of consumers, and the demand function of type 1 consumer is this, where P is the price and Q is the quantity, and demand function of consumer 2 is this, B by alpha minus P by alpha, where P is the price and Q is the quantity demanded. Now, the monopolist cannot identify these buyers. It knows that there are two types of buyers, but it does not know who is type 1 and who is type 2. So, it will choose, or it will decide, or it will design the package in such a way, so that there is something called self selection. That is, if I meant this bundle for type 1 consumer, then this type 1 consumer should choose that bundle only, and if I choose if I design a bundle for type 2 consumers, then the type 2 consumer should select that only. So, type 2's consumer should not select the bundle of type 1 consumer, and type 1 consumer should not select the bundle of type 2 consumers. Okay. So, this is the criteria of self selection, and we have to ensure that, and we assume further these technical conditions, and you will see why we need them. Okay. And for simplicity, we assume that there is 0 cost of production. So, that means marginal cost is 0 and there is no fixed cost. Okay. So, now if we plot this, so this is quantity and this is price, this is, suppose this is the type 1 where A minus B. So, this is A and this is A, and suppose this is type 2, B by alpha minus P by alpha is equal to Q. Sorry, this is quantity. Okay. So, this point is B and this point is B by alpha. Okay. Now, the monopolist can sell, this point is this. So, sell one bundle, that is for type 1 type 1 it is bundle this at some price P1, and then for B it can sell the amount this at some price P2. Okay. So, for one bundle it has to be something like here. Now, see, if we test this and if P2 is this whole area, if P2 is this whole area under this demand curve, if P2 is area under this demand curve, then P2 consumer 2 if it buys this bundle, then it gets this much amount of surplus. So, this is not an optimal strategy because it violates self selection, but here it can charge this much. So, P2 and this area is suppose B, and this area is suppose, sorry, let us denote it in different ways, otherwise it will be confusing. This is suppose this, and this is suppose small a. So, P1 can be equal to A, small a, this whole region, and P2 can be A plus B. Then the consumer 2 type 2 is indifferent between buying this bundle A and this bundle this and this, and so and we assume that the consumer type 2 consumer buys this bundle when P2 is equal to this. Now, the question is whether this is the optimal bundle or not. So, how do we do this? So, what do? We do we solve it in this form. Suppose this is x. Suppose for type 1 Q1 is x, and for type 2 it is B by alpha. Okay. This is the package. Okay. And here x should lie within this range. Okay. It can be A also. Now, within this, if this is the A, consumer 1 for type 1, it can charge this whole region for paying this. This region, this point is A minus x. So, this point is A minus x. So, this region is this rectangle into this triangle plus this triangle. So, this area is x A this plus this distance is A minus this. So, it is x, this distance is x. So, x square. So, this is the area of this triangle. Okay. And if A is equal to x is equal to A, then this is 0 and we have only this part. Okay. And so, this is P1. Okay. And P2 it can charge this much additional amount. So, this point is what? This point is B by alpha, sorry, this when we plug in this quantity, and here this is, we can write this as inverse demand curve, and x is the A. So, this point is B minus alpha is equal to P. This point is B minus alpha x. So, this triangle, area of that triangle, this dotted triangle is what? This height into base divided by 2. So, this is B by alpha minus x, because this is x. So, this distance, this is the base and the height is this much. This is the height divided by 2. So, now P2 is this, plus it can charge this triangle, sorry, this area, not this triangle, this whole area. So, that is the P1. It will get this. So, monopolist is going to choose x such that this is maximum. So, it will maximize this with respect to x, and since this is differentiable function in x and x lies between 0 and a. So, this point is, we differentiate this and equate it to 0, the first order condition, and so what do we get? And this is equal to this. This is the first order condition. So, we solve this, what do we get? We get x is equal to a minus b divided by 2 minus alpha. So, that is why we assume these conditions, we require these conditions, so that this takes a value like that. Now, if you look at this, this point is actually less than a. So, this less than a means, so this means b should be greater than alpha, and this should be positive. So, this is positive and this is positive, both, or both can be negative, but for simplicity assume both are positive. So, this ensures that we get this. Now, here this is the condition ensures that this point is somewhere here. This point is somewhere here, x. So, this is the price P1 is equal to this region, which is this, and this region is P1, which is actually equal to, since this x is equal to 2a minus b divided by 2 minus alpha. So, this is, if we plug in that here in this portion, we will get it. So, and P2 is this region plus this region. So, here we get that P 1 is equal to 2 this and this is equal to it is this, and P 2 is this, this is at Q 1 is okay. This is the bundle, this is the package at this price. P 2 is this whole thing, plus one more additional term, and that is it is this. So, Q 2 its bundle is B by alpha. So, B by alpha at this price and Q 1 this at this price. This is the way the monopolist can package the product, and it is like this. So, this much amount at this price whole and this much amount at this area plus this area. Okay. So, this is one way of bundling. Okay. So, but if we have suppose if we have a demand curve of suppose one demand curve is this, another demand curve is this, another demand curve is this, then also we can look whether so there are three types of buyers, we can see whether we can bundle it or not. So, here one possibility is that there may be three types of bundle or package, or there may be only two if it is. Okay. But here this will be much more complicated than this, because there are three types of demand curves, and we will have to look whether it is, because we have to satisfy the self selection criteria. So, consumer 1 should not buy the package meant for consumer 2 or for consumer 3, neither consumer 2 should buy the package of consumer 1 and consumer 3, neither consumer 3 should buy the package of consumer 1 and consumer 2. So, all these possibilities have to be checked. So, that is why if we simply increase one more type of consumer, the complications increases by a huge amount, but with two things it is still manageable, but the idea is, I think it is clear. So, the main idea is that if we can differentiate the demand curves, then it is possible to bundle the product. Okay. Now, we switch to another topic, and that is tying. What do we mean by tying? So, tying, here again we take a monopolist. Now, monopolist can, suppose a monopolist is selling computer, desktop computer. So, desktop computer come as a two thing, one is the monitor, another is the CPU. So, this comes together. So, this is you can think of as a kind of a tying. So, monitor is tied with the CPU or CPU is tied with the monitor, or you can simply assemble this thing and you can buy them separately. So, this is one, or if you look at MS Office. So, like MS Word, MS Excel, MS Access, all these things are tied together. So, you can buy only MS Office and all these three things are available, but each of them can be considered as separate product also, right. So, this is a tying strategy and the monopolist can follow a tying strategy. Okay. Now, it can be shown that the tying is sometimes profitable and that is why the monopolist tie. Now, here we are assuming that the monopolists are not a single good producer monopolist. So, they are producing multiple products. Okay. So, suppose there are two goods X and Y and these two goods are produced by a monopolist. Okay. And for simplicity we again take the cost of production to be equal to 0. So, that is the marginal cost is 0 and there is no fixed cost. Okay. And consumer assume for simplicity that they want both the product. So, we have some consumers and they want both the product. And these products may not be strictly complementary in nature, like in case of monitor and CPU they are complementary. You cannot have the monitor is useless if you do not have a CPU and CPU is useless if you do not have a monitor. But in case of like MS Word, MS Excel, Access, then they are not strictly complementary, although they have some degree of complementarity, but they are not highly complementary. Like you can, if you are only working, if you do not work with any data or numbers, then if you do not, you are not engaged in any form of calculation, only you require it for typing, then MS Word is sufficient and you can do it that only. But if you are engaged in both calculations and writing, then you require both Excel and Word. But if you are only engaged in calculation and you do not require need to do any writing, then Excel is sufficient for you. Okay. So, we assume that there is both the products are required by the consumer, but they are not highly complementary in nature. And for simplicity, suppose we assume there are two types of consumers and the types of consumers are differentiated based on their valuation for this product. And for simplicity, what we have done, we assumed that suppose consumer 1 value good X more than good Y and consumer 2 values good Y more than good X. Okay? And their actual valuation is given like this. Suppose we have two good X and Y, okay, and we have consumer 1 whose valuation is suppose high and this is low, and consumer 2 his valuation is low and high, and suppose these are same for to keep the things simple, otherwise it will create lot of, we will have to do lot of calculations, and here my objective is to give you the idea, not do the actual calculation. So, these are valuations. So, that means if consumer 1 buy 1 unit of X, the utility it gets is H. Net utility is this minus P X, and the utility it gets from Y is H minus P, like this. Okay. These are the price, and both we assume that both of them consumes only 1 unit of good. So, consumer 1 consumes 1 unit of X and 1 unit of Y if both of them are affordable. Consumer 2 buys affordable, or if they give them non-negative, if this is right, they will consume for this consumer 1. And for consumer 2 utility is this, okay, and he will buy both the product 1 unit of each if both of them are positive. Okay. Now, how do the monopolists price this good? It has many strategies. Suppose it does not tie, the product. So, then it means what? So, Px it can charge L. If it charges L, then profit from, because it is a monopolist, so both the consumer can buy it, so it will have 2L. This is one possibility. Or it can charge this H and profit from X is only consumer 1 buys. So, this strategy is profitable when H is greater than 2L, right. Otherwise, so if this is the case, then Px is equal to H, or if 2L is greater than this, then Px is equal to L. This. Similarly, for good Y also. So, Y is equal to L, then profit of Y is 2L. If Py is equal to H, then only consumer 2 buys. So, it is H only. So, if 2L is greater than H, then price is L, and if 2L is less than H, then Py is equal to H. So, these are the pricing strategies if it does not tie, okay? So, if tying is not there. But if it ties, it can charge a price, that is Pxy, it is a tied product. Both you have to buy both the product and you have to pay only one price, and that can be H plus. Now, here if this is the A, consumer 1, utility of consumer 1 is H plus L is this. So, it is going to be positive if this is, it is going to be non-negative if Pxy is equal to H plus 1, and this is again this if we have this. So, profit if it ties is 2H plus 2L. Now, here in this situation, if we have, what are the possibilities? Possibilities are here, either it gets, if it does not tie, if its profit is X, is 2H, or it can be 4L. If you compare with this, you will get that Py is always greater than this. So, because of this reason, we get that the tying is a more profitable strategy than not tying. So, in this situation, the monopolist is always going to tie this product X and Y. So, that is why we get certain products which are bundled together, which are tied together. We do not get them as an individual product, but we get them as a composite product where many things are together, okay? Even if the goods are not highly complementary. Okay. Next, we can see that whether only tying is a or there can be other possible way of tying. So, we see something called a mixed tying, and when do we see mixed tying? We will now do that. Again, consider a monopolist which produces two heterogeneous products, good X and good Y. Okay. And suppose for simplicity, cost of production is 0 for both the product. And there are 3 types of consumers, 1, 2 and 3. Now, we increase the type of consumer, and they are different because their valuations are different. Consumer 1 attaches positive value to good X and so demands only good X. Consumer 1 does not demand good Y. Consumer 3 attaches positive value to good Y and so demands only good Y. And consumer 2 attaches positive value to good X and positive value to good Y, so demands both the goods if it gets positive utility from or non-negative utility from them. And for simplicity, each of them buys only one unit of good. Okay? This is the setup. Now, we have to see what is the strategy of the monopolist, and before that let us look at the valuation. So, this is suppose X, this is suppose Y. Consumer 1, consumer 2, consumer 3. Suppose it values this and this is 0 and this is 0 and this, and suppose this is A and this is A, same. This is one simplest configuration that we can have, but you can complicate this, only then the calculations will be more complicated. Okay. So, consumer 1 buys good X if B is this. Consumer 2 buy X if A minus B. Again consumer 2 buy good 2 if A minus Py gives this much, and consumer 3 buy only good A if V minus Py is greater. So, these are the possible A. Now, we have to see how the monopolist is going to price this, and these informations are there to the monopolist. Okay. And here even monopolist, we do not need to specify whether monopolist can identify these types of consumers or not. Even if the monopolist cannot identify, it will package the price itself will give you will lead to a self selection kind of thing. Okay. So, that specification is not required. Now, here suppose no time. Okay. So, then Px can be suppose A, and further here we assume that suppose A is less than V. Okay. So, if P is this, then profit from X is consumer 1 is going to buy, because its utility is A by V, A minus V, now it is positive. So, it will get 1, and consumer 2 is also going to buy good X. So, it is profit is this. Consumer 3 is not going to buy this, and it can set this is equal to V also. Now, then profit is this. So, the price here is going to be 2A if 2A is greater than V, or it is going to be this if V is greater than 2A. So, it is same as the outcome we have got earlier. And for price of good Y, it can set the price A. Then consumer 2 is going to buy it. Profit of firm monopolist is consumer 2 is going to buy and consumer 3 is going to buy. So, it is 2A. If it sets the price this, only consumer 3 is going to buy. So, it is going to be this. So, following this thing, we get that the Py is equal to A if 2A is greater than V, and Py is equal to V if V is greater than 2A. If it is same, then they are indifferent, you can charge anything. Okay. Now, we have got this if there is no time. and if there is time, suppose it does time, then Pxy it can be V. If it is V, then what it is? Then the profit, and if it is V, and if suppose V is less than 2A. If this is the case, then profit from time is consumer 1 is going to get by, because it will get X, it is Y is going to be useless for him, but still he gets X and his valuation is non-negative. So, his net utility is non-negative if price is V. So, 1 consumer 1 will buy. Consumer 2, since it is this, he is going to get some positive utility if price is V of xy. So, this person is going to buy. So, it is again V. Third person, consumer 3 is also going to buy. Why? Because his utility from good Y is V and price is V. So, he is getting X, but he has no value from X, but it is still gets. So, the profit here is 3V. Okay. And if its price is suppose 2A, then this thing is going to only, if this is the case, then only consumer 2 is going to buy. So, profit here it is going to be 2A. Now, if this is the case plus 2V, and if we have suppose V is greater than A, but V is less than V, right, then we will definitely have a situation where 3V is greater than 2A. Okay? Because from this condition we get this. Even if this is true, we will get this, right. So, if they tie, then the price is always going to be this, if this is true, okay, and given this. If this is not true, then it is not going to get this. So, it will be only 2V. In that case also it is going to get 2V. So, it is going to be greater than this. So, now, so this is time, but monopolist can follow another strategy, and that is the mixed time. What it can do in mixed time? It can set one price where it is getting both X and Y at a price this, and it can set a price V this. Now, here in this situation, see, if so, what is going to happen? If consumer 1 will buy this, consumer 3 is going to buy this product, so at this, so their utility is going to be equal to 0, it is going to be 0, and for this person, for consumer 2, if it buys this and this separately, its price is 2V, but if it buys together, it is 2A. Okay, 2A is less than 2V. So, that is why it is going to buy that. So, the profit in this situation to the monopolist is 2A plus 2V, which is 2A plus V. This is greater than both this here, and it is in this case profit is how much? Profit is this and this, or it is this. So, it is profit here, it can be 4A or it can be 2 V, right. And these are going to be less than this. So, that is why we get that mixed tying can also be one possible. So, the main idea is to extract as much consumer surplus as possible, and so the monopolist can use different strategies to extract surplus. So, one is if it is possible, it will only do bundling to extract more. If it is not producing more than if it is only producing one good, then it can do bundling. If it is producing more than one good, then again it can do bundling, and it can do tying, it can do mixed tying, and again can bundle the good also. So, there are so many possibilities it can. The idea is that the monopolist will always try to extract as much consumer surplus as possible. Next topic we are going to do is tying as product differentiation. Now, here what do we mean by product? So, product differentiation, we see that the products are different to a firm producing another type of one type of product, another firm producing another type of product, and they are different based on some characteristics or some attributes of this good. Now, here we can see that suppose both the firms produce a homogeneous product, and that is suppose this X, but you require some kind of a maintenance service for this good. So, by providing maintenance service and by not providing maintenance service, you can differentiate this product. So, as a product itself, it is homogeneous, but by additional this service, maintenance service, you are differentiating this. So, for simplicity, we take that the firm can either provide the service, maintenance service, or it may not provide the maintenance service. So, this is the way of differentiating. So, you can have one product which you get the product, and also along with it you get the maintenance service. Another is you only get the product. Okay. So, in this case we see that the products are now different. One comes along, maintenance service is tied along with that product. In another, it was only the product, and if you want some service, you will have to pay it separately. Now, here we are assuming that the service is fixed. It is either you give service or you do not give service. So, it is you cannot differentiate it in terms of degree of service, that whether you will give 1 year service, 2 year service, that is not possible. Actually, to keep the things simple, and consumers consume only 1 unit of good, they get the same value, and that is this. Now, but the consumers attach different values to the benefit from the service. And how do we model it? We take the something similar to the hoteling model, and here we assume that the consumers are uniformly distributed with unit density on the unit interval according to increasing valuation of services. So, if we take this 0 and this here, suppose this is 0.1. So, this consumer located here is going to value the service more than consumer this, which is suppose located at this point, but this which is located at this point is going to value the service more than this. Okay. So, this is how the consumers are located, and there is, you can say that the continuum of consumers located in this region or in this unit interval. Each point or each dot represents one consumer. Okay. Now, suppose the marginal cost of this product is this, and there is no fixed cost, and suppose the marginal cost of the service, it is also constant, and it is this M. Okay. And in the product market, for while selling this product, that is there is price competition. That means firm 1 decides a price P1 and firm 2 decides a price P2. Okay. So, you can say that there is a butter competition, and so here we may get 3 possible outcomes, and see, and it is, you can say that it is a 2-stage game. What happens? Okay, we will discuss the game later, but first what are the possible things? One, both the firms choose does not choose service along with the product, they give only the product, that is one outcome. Another outcome is both the firms choose to give the or provide the service, that is another outcome. Or another outcome is one firm chooses to give service, another firm chooses not to give the service. Okay. So, here we get the product differentiation. In this two case there is no product differentiation. And here we see that there is product differentiation. Okay. And product differentiation is through tying a service, and the game is a two-stage game. Stage 1, it decides whether to give service or not. And in stage 2, it decides P1 and P2. Okay. So, we will consider it using subgame perfectness equilibrium. Suppose the first case, suppose both, case 1, both provides both do not provide the service. So, the utility that the consumer gets is V minus P1 if it buys from the A and P2. Okay. V is the utility and it does not get any services. So, it is same. So, here what is going to happen? If this person is given in his location here or here any point, it will choose that where P1 is, which is lowest. So, it is minimum of P1 and P2, right. So, we know here if it charges anything greater, it is not going to buy. So, ultimately here P1 is equal to P2 and it is equal to M. This is the optimal strategy, and the profit of firm 1 is 0, profit of firm 2 is 0 in this case, when both do not provide service. Okay. Now, suppose both provide service. If both provide service, then what is going to happen? Utility of any consumer is going to be this plus this if this is the location of that consumer S minus P1 if it buys from A, and it is going to be this if it is buys from firm 2. So, this remains same. So, this consumer is going to buy from that firm whose price is less. So, again here if you charge any higher price, none is going to buy from that. So, that is why there is only one possibility that P1 is equal to P2 and that is M plus W, because this is the marginal cost, sum of the marginal cost, this is the marginal cost of the product and this is the marginal cost of the service. Okay. So, here again in this case profit is of firm 1 is 0, profit of firm 2 is 0. So, Butler paradox is fully operational here and here in this two case, in first case. But in the case 3, suppose firm 1 provides service and firm 2 does not provide service. This is one possibility. Okay. Now, let us look at these consumers. This is suppose consumer X consumer S. Utility of consumer S is V plus A if it buys from farm 1, and utility is this minus this if it buys from farm 2, because it does not get the service, here it gets service. So, from this these two valuations are not same. So, we get that now the price of farm 1 and farm 2 can be different. How can it be different? See, we can find a value of S such that it is equal to P 2. And here, see, all these persons S is more than this, valuation is more than the S, all these persons valuation is less than S. So, in this case, if this, suppose this S is interior, so we assume this. Okay. So, if this is the case, then what do we get? We get that we have a S bar where P 1 is given P 1 and P 2, and this person gets same utility from buying from farm 1 or farm 2, but they are getting different product, and the in product of farm 1 is that the same product with service, product of farm 2 is only the product, no service. So, the market of farm 1 is 1 minus this S bar, this, okay, and market of farm 2 is all these consumers are going to buy from farm 1, and all this. So, if this is S bar, then this region is for farm 2 and this region is for farm 1. So, this is the farm 2. Okay. Now, we define the profit function. Profit function of farm 1 is, it will charge the price P 1 and it will marginal cost from service, marginal cost from product into, it will be serving this many people, which is equal to this, and profit of farm 2 is this. Here, while doing this, we have assumed this thing. Now, we can take this. Okay. Why? Because if, so that we get an interior thing as lies within, not here, neither here. If it is at the boundary, then it is means either farm 1 is serving or farm 2 is serving. So, it is so that means what? Either only one type of product is there, we do not see any product differentiation in this case. So, that is why we will assume this, only consider this thing. Now, here we maximize profit, maximize P 1 with respect to P 1. So, we get what? This will give you this, yes, and first order condition gives this equal to 0, first order condition. So, we get the reaction function of farm 1 in this form. this is the reaction function of form 1. Okay. Similarly, form 2 what it does, maximize P2 with respect to P2. Now, here what is going to happen? So, and we know the it is going to be this, and this is going to this. First order condition gives me this is equal to 0, first order condition. So, we get P2 is equal to P1 plus m divided by 2. This is the reaction function of form 2. Now, we solve these two reaction functions. What do we get? P1 is equal to 1 plus m plus w by so this implies P1 is equal to 1 plus two plus 2m plus not here it is also m. So, it will be 3m plus 2w divided by 3 and P2 is 1. So, P2 is 1 plus W plus twice m divided by 3. Yes. Now, what is S bar? S bar is P1 minus P2. This is 2 plus 3m plus 2w minus 1 minus w minus 2m divided by 3. So, S bar is equal to 1 plus m plus w divided by 3. So, profit of form 1 in this case is what? P1 minus w minus m minus w 1 minus S bar. So, this is 2 plus 3m plus 2w minus right. Now, here we have to assume that this is definitely greater than 0 and this is less than 1. So, we have to assume that this is less than 2 okay, for this condition to satisfy this. So, for simplicity I assume this. Okay. This condition needs to be satisfied. Now, so solving this we get 2 is this is the profit of form 1. So, this is 2 minus W, 2 minus M minus W divided by 9. And profit of farm 2, profit of farm 2 is P2 minus M S bar. P2 is this 1 plus W plus 2M minus 3M into this. So, this is 1 plus W minus M, 1 plus M minus W divided by 9. This is the profit of fund, and this is positive, and this is also positive. But in this situation, what do we get? 0 and 0. Now, here we can do something. So, strategy in stage 1, strategy of farm 1 and strategy of farm 2. So, it provides service, it does not provide service. It provides service, it is no service. Farm 1, farm 2. If both provide service, it is 0, 0. If both does not provide service, it is 0, 0. These two outcome 1, 2. So, this is case 2 and this is case 1. This is case 3 and this is case 3. Here we know profit of farm 1 and farm 2 both are positive. So, if farm 1 we have computed this, farm 1 provided service, farm 2, and we will get a symmetrically opposite here. So, we get two Nash equilibrium, either this and this. So, this we have got, this is what? This profit, no? This profit. So, it is 2 minus W. So, it is 2 minus W and then 2 minus W minus M divided by 9, and profit of 2 is 1 plus W 1 plus M divided by 9. So, in this is, and it will be opposite here. So, this will be farm 1's and this will be farm 2's. And here this, since both of them are positive, so either this is a Nash equilibrium or this is a Nash equilibrium. So, here what do we get? So, the subgame perfect Nash equilibrium outcome is that either farm 1 does provide the product, differentiated product, and farm 2 does not provide the service, or farm 1 does not provide the service and farm 2 provide the service. So, this is a form of tying where we see that both the farms are not doing tying, only one of them is tying, and the tying is allowing them to differentiate the product, and that is a subgame perfect Nash equilibrium outcome we have got. Okay. And so, tying can be helpful in this sense, and that can be a strategy which can be used in not only by the monopolist, only also in a duopolist to differentiate the product. So, from a homogeneous product market, you can switch to a differentiated product market by tying this kind of services. So, this is a very important strategy that the firm may utilize. Okay. So, this was our last class. So, I end this here, and for this portion tying and bundling, you can read this chapter 14 of this book by Industrial Organization, Theory and Application by Osai, and these are the specific page numbers. So, this is a very long chapter and we have done a very small portion of it, and so that is why I have specified the pages. So, here what we have done basically, in this CA we have done, first we have mainly our objective was to look at how the interactions takes place in a market between the buyers and the sellers. So, from the buyer side we get the demand, and so that since they are buying, so we have derived the demand. Firms they produce, so they incur some cost. So, we have done the cost minimization, and from there we have derived the cost function. Now, then we have specified different setups under which these buyers and the firms interact. First is the competitive market, where both the firms and the buyers takes the price as given, and based on that we get the market equilibrium. We have shown that the perfectly competitive market is a Pareto optimal and also social welfare maximizing outcome. Next, we have looked at monopoly. What is the monopoly price? What is the monopoly outcome? In the monopoly, there is only one firm, and we use the conventional downward sloping demand curve. And we have looked at the different price discrimination strategies of the monopolist also. Then we have introduced strategic interaction, and to do that we have introduced game theory, and we have done two forms of game, that is complete information static game, one shot simultaneous move. So, we know how to find the pure strategy and mixed strategy of such games, and then we have done dynamic games, and we have used the solution concept, that is subgame perfect Nash equilibrium. And using these two, we move to these two tools, we have done the analysis of the other forms of market. So, first Cournot duopoly, where we have shown that it is not a Pareto, it is something like a prisoner's dilemma kind of outcome, the Nash equilibrium outcome is. And then we have looked at the Cournot oligopoly thing, and we have also looked at the limit outcome of that. Then we have introduced price competition, that is the Butler competition, and we have discussed the Butler paradox under different setups. And then we have introduced capacity constraint, and then we have seen that under certain conditions the Butler paradox may not be there when capacities are not sufficiently big. And then we have done in decreasing returns to scale in the production function, and then if we have price competition and decreasing returns to scale, then what is the outcome? We see that there is a whole range of price that exists. Okay? It is, so the Nash equilibrium, pure strategy Nash equilibrium is not unique. Then we have done Stackelberg, both quantity competition and price competition, and here we have endogenized the we have also looked, not endogenized, we have looked whether there is a first mover advantage or there is a second mover advantage, and we have got that in quantity competition there is first mover advantage, and in a price competition if the goods are substitute there is a second mover advantage, but if the goods are complement then we see that there is a second mover advantage. After that we have introduced the hoteling kind of model, where we have done the product differentiation, and we have done under two setup, that is when the firms choose the location simultaneously and when firms choose their locations sequentially, and we have found the pure strategy Nash equilibrium in the first case and the subgame perfect Nash equilibrium in the second case. Next we have introduced entry deterrence to see whether a firm is deterring, because that may lead to a monopoly power in the firm. So, mainly it is important from the perspective of the regulatory authorities. The regulatory authorities always see whether the existing incumbent firm is engaged in some form of entry deterring strategies or not, and strategic investment can be a possible entry deterring strategy. We have seen that, but it is not always, not in all the cases, only in certain cases. Then today we have done the bundling and the tying, and there also we have shown the pure strategy Nash equilibrium only in case of tying when there is a we have introduced two forms, but in case of bundling we have only done it for monopoly thing. Okay. So, with this I hope that you have enjoyed this course. Thank you.